All right, thank you, Wes. Thank you, everybody, for being here. I know some of you well.
Yep.
Yeah, we're going to talk about advanced audio, but fair warning, we're not really going to talk about the applications of advanced audio. We're in the IP showcase, so we're going to talk about what's required in IP transport, particularly in 2110, to enable these advanced audio applications. So let me define a couple terms before we go forward. But what I mean when I'm talking about advanced audio today in the context of this discussion, many of you may be familiar with the term NGA, next generation audio. That's the one that's been bandied about, particularly as part of ATSC3, but other applications. And that's the stuff we're talking about today as advanced audio. And there are several features that define what we call NGA, but immersive, personalized, accessible. These are kind of some of the buzzwords you hear. And some of the systems that are out today and formats that handle it, MPEG-H, many of you heard about, AC4, some of the advanced channel formats. These are all considered immersive because they are next generation audio because they either enable immersive or these advanced features we can't do with traditional codecs. I'm going to introduce you to another new term that came out of SMPTE called MGA, metadata guided audio. And this term was coined, I'll talk a little bit about file formats where this came from, but this was coined from the recognition that there's kinds of audio that it's impossible to reproduce without metadata. And an example with that would be an audio object. You can't reproduce that object unless you know its location. So you have to have metadata, in that case, time varying critical metadata that tells you where that object is at any given time. That's an example. But there's other examples of audio that you really can't reproduce the format unless you know something more than just the PCM channels. And so there was a recognition of, hey, this is where the future is happening. All the different things we need in the future to enable advanced audio, whether it's in production, codecs, require this metadata. So it's not like an optional metadata thing. We require this. And many of the formats we're talking about in the future, VR, virtual production, what I call ultra personalized, where it goes well beyond the features of our current NGA systems, they need this kind of metadata. And so I'm going to talk about some of the features of this metadata and what's needed in an IP network to support that. So I'm going to start to back up a little to tell you what's been going on in the file-based world. Many of you know about WAV files from the audio standpoint. They've been around for many years, and traditionally this is how a lot of advanced audio has been enabled. And basically a WAV file, in particular, an example might be a broadcast WAV file, which is one of the more standard formats used in our industry. You have the PCM audio itself in a audio section, but you have these things called riff chunks. And they've been around a long time, but they've seen widespread use in lots of audio editors and carrying different kinds of data and metadata. So it's a widely adopted format. And it's been widely used to enable a lot of these next generation features. And we'll talk about a specific example with ADM coming up. That's one of these things that's gotten used. Some recent work in SMPTE has been underway on two fronts, and one is to enable these features, literally these riff chunks in MXF files, to enable broadcast applications. And there's a new standard in process, ST2131. I'm going to throw some new acronyms, new numbers out for you. I'll have a definition of them as we go along, but this one's very new, and in fact it's just out now for public CD, and there's a link to the GitHub site where you can actually go and download this and look at it. So the idea is to enable these same features that are present in WAV files and literally be able to translate these riff chunks back and forth. So that's a great start. The problem is it replicates the existing features of WAV files. It's made for basically file processing. It's not made for live processing, and it's not ideal for streaming. You can make it work, but it's not ideal. That's where this other standard comes in, SMPTE 2127-1. And that's an application that recognized, hey, we need a format for this kind of audio that requires metadata, but is in a format that's suitable for streaming and for interchange with live and for editing on a frame-by-frame basis. And that's where this term got coined. And it defines something called an MGA framework, and the metadata guided audio framework. And its basis is this thing called a frame. And this is defined in this document 2127-1, which was published last year. And basically what it consists of is bundling the audio itself with the metadata in these frames. So it's intimately associated with it. Of course, MXF can handle lots of metadata, and there's ways to put metadata in the existing formats, but this one is designed specifically to edit on a frame basis and keep that metadata intact with the audio. and this audio is contained in these audio metadata sections. And there's some more details about how exactly we enable this, but the key is it leverages what's been used in the file format for many years for universal labels, SMPTE universal labels, to identify these. And that's something we've adopted in some of our streaming formats already, and we're leveraging for this. And so it can carry multiple ones of these sections, not just one, but more than one. So you can have multiple types of metadata in a given MGA frame. And it's also agnostic to the kind of metadata. It doesn't describe what that metadata is. It's up to you and your application to define what that is. But the framework supports an extensible set of these. And also leveraging part of what SMPTE is, it allows not only public standardized metadata, it allows private metadata and even experimental data. So you can quite easily add other kinds of data to this. You don't have to wait to go through a long, complicated standards process. And if you need something on the fly, you can add it on the fly with one of the experimental sections. So that's what's going on in the file-based world with these new formats, and that's going to tie into what I'm talking about on the IP side. Where we're evolving from, where most of the work has been happening in IP transport, is leveraging the SDI infrastructure. We've had the ability to carry data through SDI infrastructures for some time, and traditionally it's been used for audio codecs. Many of you may be familiar with this, carrying particularly Dolby, but possibly other codecs like MPEG, AAC, Dolby AC3. It's enabled the AS3 channel to be used as a data pipe, and that's what's enabled a lot of the things we see on air today. Well, it turns out that can work over IP networks. Any of these standards that transport AS3 audio over IP can be leveraged to make use of that. And if you want to send the whole SDI signal, you have options with 2022-6. You can send it as part of MPEG transport. That works as well. In fact, we've been doing that with actual MPEG transport for many years. But more recently, the 2110-31 standard was created partly as a motivation to be able to carry what we call non-PCM audio, whether it's compressed audio or more recently metadata. And so that allows it. The only issue there is 2110-30 is how we'd like to carry the audio. That's the native audio one, and it by itself, it doesn't have that capability. It can be made to work, but it really pushes everything toward 2110-31, which I'll talk about. But I do need to say that this scenario does work for most of the applications that you'll see today that are practical, and it is compatible with legacy SDI. So if that's a requirement in your application, we can do a lot with this. Where its limitations come in is the AS3 pipe itself, and that's always been a limitation of how much data you can get through it, how it's timed. There's a lot of timing issues that come into play with that have been historically present for many years with SDI. And the problem is it just perpetuates itself when you carry it to IP. It's just the same problems come along for the ride. So, and particularly in the last one, it kind of tends to put you in the point, it's like, well, I'll just use -31 to carry the audio, not -30. And so, and then again, if you're using another system like Dante or something, does this really help? So it really, when we looked at it, said it doesn't really meet the requirements of what we need for these future systems. So that's where this new standard comes in, 2110-41. Now what the official title for this is Fast Metadata Framework. And its motivation was not actually audio. It was actually motivated by carrying some kinds of video metadata or things describing the streams that needed to come in a, quote, fast manner. Not necessarily varying, but early on in the process, we realized some synergy and said, hey, this is a good data pipe. We already have -40, which carries ANTS data, but it's subject to all the limitations of ANTS. You know, the packet structure and again, the legacy SDI compatibility. And again, it just carries those legacy things forward. So by itself, 2110-41 is designed to say, hey, let's get rid of all those legacy issues that may involve ANTS packing and make a new open data agnostic format for sending data. And rather than tie it to video, it can be tied to any stream. So you can not only tie it to the video stream, you can tie it to the audio stream or any other stream and leverage the 2110 framework for timing. So, but its main focus is at both getting the data there fast and getting it there in a time synchronous manner. So when you have metadata that's time critical that matches, say, audio or video, like it's frame synchronous, it gets there with the audio or video or whatever else you're doing. And I'll not go into more detail about it other than say what it defines are these things called data item packages, which are more or less payloads. So you have the RTP packet itself, and within the RTP packet, you can have one or more payloads that carry the data that you define for that application. And the documents themselves define, okay, what are the requirements for that type? So in other words, if we're streaming audio, we would say, okay, we want to synchronize it with the audio stream. And that's precisely where the next standard comes into play. And I should mention Dash 41 and this standard here, 2127.2, they are active in committee, currently in development. They're in the ballot process, but they're pretty far along, and we've reached a good technical consensus. So what I'm showing you here is a good likelihood this is what's going to end up in the published standard, which I hope will be through committee later this year. So I mentioned this MGA frame defined in the file format earlier, right? The goal of 2127-2 is to take those exact metadata sections, since they're already frame aligned with a group of audio, and put them in these data item packages defined in Dash 41. And so we basically take the same data, and again, it's data agnostic to whatever it is, and you can have one or more of these items, and we package them in an RTP stream of Dash 41, and we say, hey, that RTP stream that carries this data is associated with some other stream carrying the essence, which ideally would be Dash 30. And through the RTP timestamps and the other requirements that 2127-2 lays out, we are able to keep these in time and synchronized. And this is what's going to enable this. And then that's what completes our workflow. So when we're talking 2110 for advanced audio, that's where we'd like to go. Now, I do have to mention this is not necessarily compatible with legacy SDI. So if that's your primary motivation or a key requirement, you do need to look carefully at what you're doing. You can do this in a manner that is compatible, but maybe in fact the earlier method is more preferable right now. But this, in the future, in an all IP network, is where we see things going. And not only does this get your data through there, it achieves something I've worked on for many years, which is parity with file formats, that when we go seamless interchange of live and file formats with no loss of data, and we can do live just exactly what we can do with file-based formats. So that's where we're headed in the 2110. The last piece of this puzzle, to talk more specifically, is where this format called ADM comes in. If you haven't heard of it, it is an international standard, it's an ITUR standard audio definition model, and it was defined several years ago. And the actual ADM itself is basically an XML file format. And you'll see some example code here. It's just a bunch of XML that describes the audio, and it's a very feature-rich format. It has huge amount of extensibility for describing all sorts of kinds of audio data. And it's still, even though it's published, it's been undergoing revisions, and it's actively worked on. And we're seeing a lot of synergy right now today, as this is a key format. Not necessarily the only format, but it's a key one that's motivating a lot of the current work. What was also an important part of the work that the ITU did was they not only standardized the file format version of this, ADM, they standardized a serial version of this. So it's basically the identical data, but formatted in a way that's compatible with streaming, live streaming. And you can format things on a frame-by-frame basis, which enables switching, context switching, all the features we need in a broadcast environment. And so it as well can be native XML, but there's also, for efficiency reasons, a gzip format defined. But the good news is that all the synergy we've seen on these efforts is these are open standards that are codec agnostic, system agnostics. There may in fact be some profiles you may need to implement to make this work in a particular system. Like if you're using MPEG-H, you may want one profile, AC4 you make another, but even there's a lot of work to make a common profile that's truly format agnostic. So this seems to be a current focus. And again, I mentioned we're not limited to ADM data, but right now that's motivating a lot of this effort. So where does this fit in that earlier picture I showed you? Part of what was defined in the 2131 was support for these ADM riff chunks. So again, they're already used today in B-Wave formats, and 2131 has specific support for them in the riff chunks that would be contained in MXF. From there, one can do a translation from the pure ADM riff chunks to serial ADM sections in this new format, 2127.2. And again, that's no loss of data. It's identical data either way. So if you're doing from file to live, you can convert that to that file, stream it out live, lose nothing, and vice versa. If you're recording, you can record it to 2127-1, convert to 2131 and lose nothing. And so that's what's ideal about this. And so again, these riff chunks, we're not using the identical data, but it's synergistic with that. And so in addition to the serial ADM data, you can carry all the other kinds of metadata you want. So where does that fit into the picture? Well, here's the picture we're talking about for, to use today's example, next generation audio, which are, the things we're talking about with the current features, AC4, MPEG-H. Use that same diagram I showed you where we use -30 and -41 to carry this audio metadata, in this case, serial ADM metadata enabled by these new standards. And that can flow natively through a 2110 network and seamlessly exchange this with file formats. And so we have kind of this hybrid infrastructure where it virtualizes live and file, and you can seamlessly go back and forth. And that's also been one of our goals for many, many years. So that's where all this work is headed. Just to comment on this, we do have a prototype that's running. We've had Dolby ourselves have had a open source tool that we've used for demonstrating other advanced audio features called PMD Studio, and it's been available on GitHub for a couple years. And internally, we have developed a version of this that's compatible with all this stuff I've been telling you. And we've got a prototype implementation of -41 running with this draft version of 2127-2 using this serial ADM data, and it enables this GUI here shows an example of some of the kind of data that we do as in a current metadata generation for today in describing objects and languages, things like that. And so it gives you a rudimentary prototype implementation. We happen to be using a Mellanox card to enable this, which happens to be have a lot of features that are useful for prototyping and implementing these things. I should also mention -41. The other app, it's not specific to audio. It works for other things. We envision new formats coming out as well. So if you're interested in -41 at all, this might be a good prototype to get started working in development with -41. So as these other formats come out, you have a platform to leverage with these. So it just happens to be a good platform for that. So if you're interested in that, please do contact me for more information. I'll let you know. But it appears, based on the current strategy, that audio will be the first application for this, and hopefully both standards will come out at the same time. Again, we're hoping to get through committee this year and publication soon thereafter, if not this year, hopefully early next year. So that kind of gives you a preview of where things are going. So I've thrown a lot of new standards and new terms at you, and this page is kind of a summary of those. And some are published as of last year, and some are currently in development. And as I mentioned, 2131 is currently available in public CD. The rest are still in committee. I've also added a couple here which are helpful if you're into IMF, immersive interoperable master format. There's some associated IMF plugins that will help enable these two formats for both ADM and SADM, leveraging these standards. And so we see equivalent support coming for those of you that are interested in IMF. So a lot of new terms. This is work in progress in SMPTE, showing you a preview of where it's headed. So a lot of the base standards are covered, but this is one of the things that's active in committee right now, is getting these through to enable these new features and new applications. And with that, I think I've caught up on a lot of the time that Andreas used. So I think we're on track here, so I'm available for any questions if you'd like any. So,
okay, thank you, Kent. Questions?
Thank you.
I might be a newbie question. What's RIF? What does it stand for, and what is it?
It's been so many years I've forgotten what the acronym stands for.
Okay, well,
it came out of Microsoft.
but what is a RIF chunk? What is a RIF chunk?
Basically, when the WAV file format was formatted many years ago, Microsoft came out with a spec. It was never standardized officially by them, but it was just a way of saying, hey, let's carry metadata. Initially, it was like artist metadata, things like that. Here's the artist, here's the programmer. But they had the foresight to define these things called what they call RIF chunks. So you can define as many of these things as you want. And there turns out a lot of people in the audio world have used those for many years to define lots of things.
Are they like preamble? Or are they embedded in the stream in a
Well, they're files. They're the WAV files. And if you go look at a
Right.
file, you'll see these things called RIF chunks.
Okay, so they would typically be probably at the head of the file, so you can access them first.
Yeah, typically at the head or the footer of the file, one or the other. So they're
So they're not embedded in the file itself in real time.
No.
So I don't do RIF chunk for different times.
That is correct.
Okay.
As far as I know.
Resource interchange file format.
There you go.
Thank you. Any other questions? All right. Thanks a lot, Kent. Really
Okay,
appreciate
thank you very
it.
much.
If you'd like to get more information about this, get a copy of the presentation or whatever, see Tina. She'll be coming corner shortly, I hope, and get your badge scanned, and we'll get you that information. So thank you.